Okay, hi. I will be presenting my simulation activity for Module 4. We're given uh, the request to do a distribution on a square-shaped plate according to the presented boundary conditions and dimensions. And for this, I use console basing on a heat transfer in solid simulation with a time-dependent study. We first settle for a square uh, geometry with a side length of 1 meter. Then I defined the material as aluminum, as it is a quite common material to have in industries and manufacturing, and it's quite a simple material to run simulations under the experience that I've had with other uh, softwares and overall studies. Now for the definition of the boundary conditions, we settle for defining temperatures in the right and the left and bottom side to 100 degrees Celsius. And for the upper and right side, we define 200 degrees Celsius. And then we define our mesh. Given that we need 50 nodes per side, we set a maximum element size of 0.02. This is based on the total length of our square. Now we settle our settings for the dependent time study. We computed and I obtained the following results for our temperature plot. First, on a time of 1,000 seconds, I obtained the presented surface temperature plot in the Celsius with a maximum temperature of 206 degrees Celsius and a minimum of 94.4 degrees Celsius. On the graph, we can see that the temperatures correspond to the boundary conditions settled and defined, where the heat transfer in conduction through a solid aluminum plate will heat will flow from the highest temperature, which is 200 degrees Celsius on the upper and right side, to the lowest heat and temperature defined, which settle on 100 degrees Celsius on the left and bottom side. Also, we have the contours for the uh, temperatures on the plate and running a animation, you can see a little bit more of the heat flow going through the aluminum plate. This makes sense with what I already mentioned, that heat will flow from the 200 degrees Celsius to the 100 degree Celsius, making, well, sort of increasing this side, and this side will flow towards the bottom left side. So yeah, that's all.